Hi, Joel Rollins here for Rave Radio, Rave Television on day 4 of a very busy ISE 2016. And I'm sitting here with Dr. Kevin Sanderson, who is with NSG Group, and they are developers of some very, very interesting high-tech glass. Dr. Sanderson, thanks for being with us today.
Thank you very much for spending time with me.
One of the things I've been talking to Annabelle about as we roamed around the show was how much of our industry is dependent on glass and the different kinds of glass that it uses. When I first got involved in installing AV equipment, I learned a bitter lesson on port glass for projection booths, because I tried to use window glass and discovered what a double image really is. So talk to me about NSG's development and the kinds of glass that you work on.
So NSG Group operates in sort of a broad range of sectors on a global basis. We have a technical glass division, we have an automotive sort of division, and we also have an architectural division. And we're here at the show actually showing off some of the value-added products that we're introducing for sort of the glass industry, and sort of particularly for the digital signage and sort of the integrated system sort of type devices.
What do you see as the big needs in glass today in our industry? What are the drivers as far as the AV industry goes in glass?
I think sort of we're seeing more and more use of digital signage, and sort of that poses some challenges for the glass. So everybody wants to see through a piece of glass, but actually sort of that poses some challenges when you put it outdoors in different light levels and things like that. So for example, we've introduced sort of very hard, durable, anti-reflection coated glasses that actually allow sort of improved transmission. Sort of we've got sort of some of the novel glasses which actually allow sort of mirrors or mirror appearances. And we're also sort of thinking about how you actually manage the heat flow into and out of some of these devices. So very similar to what we see in architectural and actual sort of cars, it's important to actually control the heat flux and sort of how much light and sort of heat comes in and out of the devices.
I never really thought about controlling heat, but in touchscreen, I can see where that could become important. So you're actually saying you're developing glass that helps dissipate heat from a device?
Either sort of helps the heat management. So whether sort of you reflect that heat to stop that heat coming into the device, and sort of or actually sort of absorbing it and then helping the management of that heat. Because sort of if the heat actually is in the device, then sort of that's got to be dissipated in some way, whether it's sort of through big cooling fans or air conditioning units. So if we can actually reduce that whilst maintaining the visual clarity of the glass, then sort of it's got to help everybody.
Yeah, I mean, obviously another thing that we have as an issue in the industry, and I mentioned to Dr. Sanderson before we started this, that I run a design and installation company when I'm not here interviewing people for Rave, and that I made an early mistake in my career with not understanding that port glass for a projection booth was a very different kind of glass than window glass, and it cost me quite a lot of money. Controlling reflection seems to be important, and yet, for instance, in my hotel here, I walked into an elevator with what I thought was a mirrored back wall, but then I can actually get messages from behind it. So in terms of that, it looks like you have several different kinds of glass for doing that.
That's it. We have sort of a Pilkington OptiView range of products, which is actually designed as the anti-reflection to sort of aid the visual appearance, and address the issues of high reflection levels that you sometimes see in certain instances. We also have a Pilkington MirrorView sort of range, which actually, exactly as you sort of say, acts as a mirror when the display is off behind it, but actually when you turn the display on, all of a sudden you can sort of see all the information that people are trying to sort of convey to you.
I can see where that could, I mean, I've seen some digital mirror systems here, for instance, that stores are starting to use, where you can try on clothes in the mirror and all that. And yet, when you're not active with them, they don't act like mirrors. So, I mean, they're basically a big LCD screen. So you're saying with the use of your glass, you could actually beat that, have it look like a mirror when it was off, and then have the image appear from behind it.
Exactly. So the glass sits in front of a display, and sort of when the display is off, sort of it looks exactly like a mirror. When the display is on, then under those circumstances you can see the information. And the next generation of that is then an interactive sort of method of that. So people will want to touch the mirror and want to interact with it and actually interact with the display. So that's the next level of generation that sort of we anticipate coming along, and we need to make sure the glass and the properties of the glass are compatible with that.
What do you consider, I mean, obviously you know quite a bit about our industry. What do you consider the challenges for developing glass for our industry today?
I think it's very important to sort of work as a partnership and together with the manufacturers of these ever more complicated and sort of connected devices. And sort of the glass manufacturer can play a key role in sort of that development process. We need to understand sort of the sort of requirements, and actually sort of we also need to sort of take into consideration the limitations sort of glass as it currently stands, and sort of challenge R&D to actually look sort of to address those issues.
So, and the stand number here is, for those of you who are still here, anybody have that?
That's a very good question. Is that it?
8H380, folks. And for those of you who are exhibiting digital mirror systems here that don't act like reflective mirrors when they're turned off, you really should come by and see it. Dr. Sanderson, thanks for being with us.
Thank you very much for your time.